welcome and thanks for joining this talk about serverless API development with serverless.com, Apollo, and GraphQL. So in this talk, I want to give you a brief overview about GraphQL itself, the Apollo GraphQL runtime, and serverless.com as a framework to write infrastructure as code, which is then used to deploy, in our case, a GraphQL API into a cloud platform. I will show this later in a short demo, but before we can do that, we of course have to have a look into a bit of theory first. And I would like to start with GraphQL. So GraphQL has been developed by Facebook in 2012 and then publicly released in 2015. And since November 2018, a new GraphQL Foundation has been established, hosted by the Linux Foundation, which is great because this let the GraphQL community grow very fast. And yeah, what is GraphQL actually? So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. So what does that mean? While REST is organized in resources and endpoints per resource that provide you fixed data structures, GraphQL provides you or grants you access to all data of your API. And to be able to do that, you have to describe your API, the data of your API in a so-called type system, which is then being used by the GraphQL runtime to fulfill your queries, and which is the basis then for GraphQL and the contract between the client and the server, which both sides can rely on. So, as I said, it's based on a type system. Let's have a look into such a type system. GraphQL requires, and this is within the name, it's a query language. It requires at least one query. You can have multiple of them, but at least one is absolutely mandatory. Otherwise, you are not able to run or deploy GraphQL API. Those queries can work with simple data types like integers and strings and booleans, but you can also bundle those simple types into so-called input types. So as you can see in the upper right corner, there's an article input type, which describes your input parameter in a more structured way. So in this case, we have an article input field or type that requires you to send a title and a text of type string and an author ID and so on and so on. Next to queries, we have so-called mutations. So while you use queries to read data from your API, you can or have to use mutations to write data into your API. And those mutations do work with the same types of input parameters, so bundled input types or single data types. And both queries and mutations are covered by so-called resolvers. So the resolvers are the ones where you have to implement your business logic in to read data from your backends, your databases, further services, wherever your data are stored at. This is what you have to do within resolvers. And this is where the GraphQL runtime will forward the requests to. So this is a very simple type system that I have written here. So types can also inherit from or implement interfaces, and we have enumerations to make a bit more clear which type of information or fixed list of data are expected by a query, for example. So that's pretty simple. There are a lot more functionalities and things you can use within such a type system. But we have to keep that in mind for an example later. So what are the benefits of GraphQL? So GraphQL provides you an out-of-the-box validation and type checking tool, which is shipped with the GraphQL runtime. As I said, the runtime is responsible to work based on the type system, and you do not have to validate your incoming content anymore. So this is what the runtime is doing for you by validating the parameters against the types of your GraphQL API. So if you send a string, or a parameter where an integer is expected, then the runtime will already send the client an error message and telling the client that the query is invalid, and you do not have to write a single line of code to validate your data. You can rely on the fact that those data are validated already, which is very cool and saves a lot of time. Next thing is API evolution without versioning. So it's a pretty common pattern to have a version identifier within an endpoint of a REST API, like version 1, version 2, so that clients or consumers of your API can decide which version of your API is being used. In GraphQL, we have just one endpoint for our API, and it is simply easy, or it's pretty easy to simply mark an entire query or single fields within your type system as deprecated. So you can mark an existing query as deprecated and implement a new one right next to the existing. And whenever a client is using your deprecated functionalities, then the client is being informed about that he's using deprecated functionalities that might disappear in the future. Next thing is performance. Due to the fact that we just have one API endpoint to query all the data, there is no need anymore to send multiple requests to get information, which is, of course, also saves a lot of time, and therefore it supports better performance. And the biggest benefit from my point of view is that we get rid of the problem of overfetching and underfetching. So what does that mean? So overfetching means that you have a resource, for example, a user resource, and you just need the name of a user, but a REST API would provide you all the other information like a birth date, address information, and email address. So things that you actually not need for your particular use case, but you get them transferred, which is also has also an impact to the performance. And even worse, you have underfetching, where you need data from your API, but you have to perform several calls to get all of them. So let me use this underfetching and overfetching issue to describe the differences between REST and GraphQL. So please imagine following use case. Let's say we have a blog system where users can log in and write articles and comment on those articles. And we have a landing page where we want to list all articles of our blog system, including the name of the author who has written the article and the latest 3 comments for each article. What would we do in REST? In REST, we would first call on the left side the articles endpoint and get 20 articles. And in worst case, each article has been written by 20 different users. And then we have to send 20 different or 20 further requests against the user endpoint and to get the names of the users, and then 20 further requests to get all the comments for your articles. Of course, this highly depends on how you slice your resources. And this is, of course, a bit of a worst case scenario, but I think you get the idea. So how would that look like in GraphQL? In GraphQL, you would send one single post request against your GraphQL endpoint. And the post request contains a query in the body content of the post request. The GraphQL runtime will take care of validating your query and forwards the query to your resolvers behind this query. And the resolvers will then take care of calling the user database, the article database, and the comments database. And GraphQL will also take care of aggregating all this information and provide only the fields that have been requested within your query. So this is an example of how such a query could look like. We would have a get articles query where we have a parameter to limit the number of results to 20. And we want to filter for articles that belong to a category A. And for each article that is being provided, I just want to have the title and the text of the article. For the author who has created the article, I just want to have the name. And I have a subquery contained here that provides me the latest 3 comments for each article. And for each comment, I need the text and, again, the name of the author who has left the comment on the article. So this is how we would call how we would call an API to solve our landing page use case for a blog article system. just as an example. But of course, there are not only benefits, there are also challenges if you work with GraphQL. And the main challenges are caching. So since we do send, or GraphQL just support post requests, and we send over a JSON body in the post method, we cannot cache those requests using CDNs. We have to care about that on backend side where necessary or where possible. GraphQL also do not support binary transfer, so means if you want to send binary files to your backend, then you cannot do that using GraphQL. And GraphQL breaks with the HTTP specification. So even if there went something wrong on backend side, you will always get a 200 HTTP status code provided to your client. The post response will contain a very detailed error message, but the HTTP status code is always a 200, which suggests that everything is cool. So you have to take care about proper HTTP status code handling in an API gateway by mapping these error messages into your particular HTTP status code. And another very big challenge while working with GraphQL is to think GraphQL. So as we have started working with GraphQL and introduced it in our project, we actually did that several times because we, of course, had just one GraphQL endpoint, but we have started implementing our GraphQL queries like we did in REST. So have one query per resource, and this is obviously not the way how GraphQL is meant to be used. And this is really a mind shift that you have to do if you want to start working with GraphQL. As soon as we start talking about microservices, then we automatically have to start talking about how we deploy them. So if we introduce a new service or new service infrastructure or microservice landscape, then we have to think about the technology that we use. So which language, maybe we use Spring Boot or something like that. We have to think about the application server that needs to be deployed, where the application is running in. Which instances are used, the number of virtual machines, or do we use frameworks like OpenShift? And we have to size them in terms of memory and CPU and storage to cover our load peaks. And we have to think about failover scenarios and scaling to cover the load. And once everything is in place and has been deployed, we have to care about monitoring. So we have to check if our instances are healthy and memory and CPU and load is everything is fine. And we also have to operate these machines because there might be a security update that needs to be deployed to the virtual machines. And all of these tasks take so much time and prevents us from focusing on what is actually important, which is the service itself. So serverless is something that can help here very well. So running a GraphQL API, microservice or API is a perfect fit for a serverless infrastructure. Serverless architectures are very, very efficient. So set up a function is done just within minutes or let's say a few hours. You don't have to care about sizing anymore, and also scalability, because this is something the cloud provider will take care of for you. And since it's not a real server, you also do not have to monitor or operate them. And the biggest benefit of serverless infrastructures is actually that you do not have to pay for idle time. So you all know we have dev systems, test systems, UAT systems. And even if they are not used, you always have to pay for them because the machines, the servers are running all the time. This is not the case for serverless functions, because you will be charged just for requests and the runtime of the serverless function itself. And this, of course, is very efficient and helps to react quick and support agility and drives innovation. I have mentioned that GraphQL is a query language and a runtime. There are several runtimes available to run a GraphQL API. So you can use, for example, Java or Golang or Node.js or PHP. So whatever you prefer. What we use in our setup is Apollo GraphQL, which is based on Node.js. And this is the runtime that is used to validate your request, or is used to run your GraphQL based on the type system, and to validate all your requests and forward the information to your resolvers and so on. So it's a very lightweight, and it also ships a so-called playground, which is a simple HTML page that you can use to test your API, to write queries and check what the API provides for your query. And also the auto-generated API documentation is something you can see in this playground. We will have a look on that in a second. The next thing is serverless.com. Serverless.com is a framework to write infrastructure as code. As you know, the cloud providers like AWS, Azure, or Google, they have their own concepts to do that. There is AWS CloudFormation, Azure Resource Templates, or Google Deployment Manager. And if you decide to go with one of the cloud providers, then you have to learn this language. And especially for just deploying, and I say just serverless, because cloud providers do offer a lot more instances and tools that you can use. And CloudFormation or resource templates are able to set up the whole zoo of features in the cloud. But serverless is focused on serverless infrastructures only, including the surrounding infrastructure like an API gateway, authorizers, shared storage, permissions, to get everything sticked together. And it's not that complex, but very powerful, and you can write or set up a whole infrastructure, serverless infrastructure, just with a few lines of YAML code. And all these three tools together are a perfect fit to start quick with serverless infrastructures and GraphQL APIs. It's very efficient, cost efficient, and has very less onboarding overhead because it's simple, very simple to start with and simple to learn. And it's obvious that this then, of course, also supports agile project approaches and drives innovation. So then it's time for a short demo. Let me, oops. So that's what I wanted to show you. So for the demo, I have set up a small GitLab repository with an even smaller project, which deploys or is actually a simple Hello World GraphQL implementation. It's based on TypeScript, and this is what we deploy into the what I deploy here into the cloud platform. Therefore, I have two YAML files in this code, one for AWS and the other one for Apache OpenWhisk, which is the basis for Adobe I/O runtime. And to have a look into that serverless file, so this is where the magic happens. So the first lines are just a bit of overhead regarding packaging. The interesting part starts here in line 34, where we define the provider. In this case, it's AWS with a runtime of Node.js 10 for my dev stage and my European region in AWS, and the memory size. Memory size here is a bit of sizing, but it is more meant to set up because this is something that AWS, for example, is charging for. So you can tweak performance a bit with that, but you also actually do that to have an impact on the pricing of your serverless functions. And then we continue with the function section, which requires a handler. The handler is points to your entry point of your code. In this case, it's a small piece of JavaScript that then starts my Node.js application. And this is where all incoming requests are being forwarded to. And then we have an event section. So these few lines here are taking care of setting up an API gateway to make the serverless function publicly available. So let's have a look how this looks like for OpenWhisk. Same, more or less the same structure. Provider in this case is not AWS, but OpenWhisk. We set up the stage and the sizing. And again, we have a handler implementation to get the application started, a name of the function, and in case of OpenWhisk or Adobe I/O runtime, we just have to mark the actions as web actions, so as web export, and Adobe I/O runtime is taking care of providing an endpoint to get access to these functions. So, and as you have seen, these few lines of code in case of AWS provide me this entire AWS CloudFormation stack, which contains an S3 bucket where my application code is deployed to. It provides me the necessary EM permissions and an API gateway and the Lambda function itself where my magic is actually happening. And here is the API gateway, which is being deployed just based on the event section that you have seen. We have a demo endpoint here, which supports an options method and a post method. This post method has an integration Lambda proxy request, which forwards the incoming request to my Lambda function. And we also have a playground where my playground, the one that I have mentioned, is being rendered then or being accessible. And here you can see this is my Lambda function deployed by serverless.com and which is connected to the API gateway. And yeah, let's have a quick look to the playground. So this is the AWS variant here, a very cryptical domain, which is being auto-generated by AWS. But you can, I hope you can see that we have here my endpoint. It's stage dev and my endpoint demo and the playground. Behind the playground, we have this HTML page that I have mentioned, where I can start writing my query, which can then be executed, and I get results back from my Lambda function. Simple hello world in this case. And on the right side, we have the docs section with the auto-generated API specification or documentation, which will automatically change once you make a change to your GraphQL schema. So this is where you can play around and test the API. If you are a consumer and want to connect to the API, you can visit the playground in your stage system and test what you do. And the same piece of code has been deployed to Adobe IO Runtime.net, as you can see here, https Adobe IO Runtime.net, which is deployed as a web action, a Node.js-based web action, and I have the exact same functionality. I can execute it and get the results provided. Docs are available, so this is exactly the same. So that's so far for the demo. And yeah, what's next for you? Hopefully, I really want to encourage you to get in touch with GraphQL and its paradigms. Please take GraphQL into consideration whenever you have to implement a new microservice, or if you are in the comfortable situation to implement a microservice landscape from scratch, then think about your use case and check if GraphQL could be a valid option for you. And focus on what is important, which is your application and not the infrastructure. Don't waste too much time anymore on planning and setting up monitoring and operating infrastructures, and simply start working with cloud infrastructures. You can do that by yourself, like I did here. I've created an AWS account for myself and tested some sample projects. It's really, really simple. And yeah, just do it and enjoy the simplicity and beauty of serverless infrastructures. And having that said, I'm done with my presentation. Just want to say thank you.